So our special guest today is Steve Jacobs of Ideal Group, which is a spin-off of NCR. He's got a lot of experience gaining grants and doing projects related to accessibility from the US government. And there's an imminent call for proposals for £200,000 a year for 3 years for a number of projects relating to community living for disabled people. And we won't get into that today, except towards the end of the meeting. But one of the cornerstones of the proposal he'd like us to do is an accessible conversion pipeline for STEM subjects, particularly, I think, mathematics. I'm delighted that we've got Jonathan Godfrey here, who is personally an expert in disability, being, can I say this, that you're the first blind statistics lecturer in the world, and you've done it, so to speak, the hard way, which is without having an example to follow. So your insight is going to be very important, and I think all of us have got some special interest in accessibility. So I'd like to now go over to Steve and ask him to give the whys, not the technical details. I don't think we want the technical details at this time, but why an accessibility pipeline is a good idea.
Okay, that's a big question. Most often, math students with what we call print disabilities, and we define print disabilities as being a disability that prevents an individual from acquiring knowledge by reading text. Maybe the individual is blind or has low vision or dyslexia, or maybe a mobility disability and they can't turn pages, or a learning disability, or they're just not good in math, or the way that math is being taught doesn't cater to their style of learning. This is a field that we've been interested in and involved in for at least 16 years. So my interest and the interest of our company and many of our partners are to provide tools and applications that make the process of learning easier, because these tools convert printed math books or digital content that includes math. Most often they're PDF files. Very often the PDF files were created using some kind of we call them native PDF files. They may have been created using LaTeX or LaTeX, however you choose to pronounce it. And we take the source document with our software, and there's a lot of software on the market that does this. We could take a high quality image-based PDF document containing all kinds of equations and automatically convert it into either LaTeX or HTML or Word XML. And in doing that, we begin the process of making it easy to present students with disabilities the type of educational materials they need that are accessible to their assistive technology, like screen readers. The process isn't perfect. It does take some human editing, but it is most successful when the source documents are of a 600 dot per inch quality. Then we're able to do things pretty accurately, with a couple of exceptions, and that is charts and graphs. Those obviously presents some problems. So my thought for a proposal would be to develop what Jonathan mentioned, is a pipeline that would enable any instructor to upload their source documents that they use for teaching to this pipeline, and then offering their students the ability to download that content in whatever format best suits their needs. It could be an ebook, it could be Braille or large print or audio, or given MathML, they would be able to use screen reading technology to explore an equation, with nested stuff in it, and I'm not a mathematician. So that's the idea. Sounds pretty simple. And I don't know if I've achieved the objective you asked me to, Jonathan, but that's really it.
I think you've done more than enough to get us going.
Okay.
So maybe I'll say a little bit about pipelines in Unix, because it's a different concept, really. In Unix, pipeline is where you have a bunch of little tools, and a pipeline is a way of combining them. So if you've got a document that's got words, and you want to know what are the 10 most frequent words, you have a utility that takes the input line by line, and it emits the output word by word. Then you have another utility that sorts the input. And then you have another utility that is called unique, that given sorted inputs, counts how many each occurs. And then you have another sort on the output, and you make it numeric. And when you put those components together, you get the information you're looking for. So Unix pipelines are very small pieces of software, generally very small pieces of software, they can be big, that fit together nicely, a bit like Lego, if you like. And the conception you have, I think, is a sort of, here's a monolithic pipeline that will be useful. And if the monolithic pipeline is made out of useful components, then those components can be rearranged in a flexible way. So that's how the Unix philosophy, I think, would change the approach to all of this. Do you want to add anything as a Unix user, Nelson, to that?
No, I think you said it pretty reasonably. The important thing about pipelines in the Unix world is that data streams from one process to another without ever being materialized in a file system. It goes entirely through kernel buffers and therefore is really quite fast. And the convention is that what flows through that pipeline is just plain text, ordinary characters. Almost never does one use pipelines for streaming binary data. That is extremely convenient because it means you can now debug such a possibly complicated sequence of processing by sticking in a snooper right in the middle of the pipeline at the appropriate point, and you can see exactly what's going by. You don't have to get into the source code of any of the programs producing or consuming the data. You merely examine the data and try to determine where the problem lies. And unfortunately, in the desktop publishing world, in fact, the Windows and Apple environments, they have gone in in a big way for proprietary binary formats for many, many kinds of files. Microsoft Word, for example, for many years was not documented at all, and people had to reverse engineer it to try to figure out how things were stored. And yet, if you think of text processing examples, such as counting words, finding the most frequent words, doing spell checks, and so on, these are all very general tasks, and they shouldn't have to deal with proprietary or complicated formats. All we really need is a stream of text. And designing software to deal with text in that form really is a good intellectual exercise. It makes you think, how can we simplify this so that all we're really dealing with is a simple input stream and producing an output stream? And that is something that most operating systems have never understood, but in Unix, it's been exploited to the hilt now for about 5 decades.